Good afternoon and welcome to today's webinar presentation focused on clean renewable energy technologies. My name is Jennifer Andrews and I'm the Director of Program Planning at Clean Air Cool Planet, which, as many of you know, has been finding and promoting solutions to climate change for more than 10 years now in the Northeast. We have with us today Dwayne Escola and John Papa, who are going to tell us about the opportunities that clean alternative energy sources offer to citizens, municipalities, and businesses in Connecticut and around New England. First to present will be Dwayne. Dwayne is an electrical engineer with a Master's of Science from San Jose State University in Silicon Valley, California, where he worked for IBM. He has over 25 years of electrical engineering and management experience at IBM, and he brought to Northeast Smart Solar, otherwise known as Northeast Smart Energy, the enthusiasm of Silicon Valley and the leadership and management skills developed at IBM. Many of the dozens of photovoltaic solar designs completed by Northeast Smart Solar are the work of Dwayne and his assistant. Dwayne is an accredited solar installer by the North American Board of Certified Energy Practitioners, as well as a certified carbon reduction manager from the Association of Energy Engineers. Prior to founding Northeast Smart Energy, he was also the general contractor for homes in California and in Connecticut. He's also very involved in Ridgefield, Connecticut's Action Committee for the Environment and other community service activities. For his hometown, Dwayne completed a community-wide greenhouse gas inventory using Leahy software. Next to present will be John Papa, also of Ridgefield, Connecticut. John graduated from Xavier University in Ohio with a finance degree and went on to work in the capital markets intelligence industry during the 90s. During that time, he was co-founder of the Carson Group, a global 300-person firm advising public companies in Wall Street. Over the last 10 years, he's transitioned from Wall Street to Main Street, from technology to biology as a farmer, electric transportation enthusiast, sustainable apparel supporter, and alternative energy user. John also is very involved in his local community. He's known as Zero Hero for his exemplary efforts to reduce community waste and to promote the benefits of recycling and sustainable technologies. He also presents testimony at the state level on electric vehicles, green transportation, and related proposed legislation. And we're so pleased to have both of you gentlemen with us today to share your expertise. So without further ado, I'd like to turn the webinar over to Dwayne, who's going to start us off talking about photovoltaic solar energy. Dwayne?
Thank you, Jan. Wow, there's a little echo. I'll get used to that. This is you'll have to first forgive me for having kind of a raspy throat voice today, but let's get started. I understand that most of the audience are either education majors or teachers, and so I put in a few slides just oriented to teaching and listing some of the items that need to be addressed in order to get students ready for the solar or the renewable energy industry. The first slide I have here is of some pictures of solar systems that we've put up. One that I'm kind of very proud of is this carport, this area here in front of this gentleman's garage, where we put some solar panels, and he's standing there in front of his electric Chevy Volt. So there's other pictures here of industrial, commercial complexes, and also, of course, a typical house. Now, let me get started by just letting you know, or reminding all of us what renewable energy and solar voltaics systems are all about. As you know, that renewable energy is there as long as the sun keeps shining. It's distributed, and this is really key. We don't have to go anywhere to get it. It comes to our home. We don't have to fill a tank full of sunshine and ship it from Iran. It's here already. It's a proven technology. It's been around since the 70s. It's economically feasible. We'll get into more of that later. No moving parts, so it basically lasts forever. It's been on homes in California for 30, 40 years, still working. There's very little CO2 emissions in the manufacturing. It only about a year, year and a half or less than 2 years anyway, to in its life cycle to counteract that. And then, of course, the next 20, 30, 40 years is CO2 free. Offsets peak load. That's key because the utility companies sometimes complain that this is just something that happens at one time during the day and then it goes away, and it's a problem for them. But it's really not, because most of the big demand is in the daylight hours, and especially in the summer, in the air conditioning time, solar is at its peak at that time of day. It reduces, as we already mentioned, our dependence on foreign oil and adds local jobs. Now, for the skills that are required, this is for the teachers in the audience. It really covers almost everything you teach, and maybe some things you don't teach. Starting out with just the solar, our sun and earth system and how it works. When I mentioned math, especially geometry, electricity, the PC, internet is a useful tool that we all use every day. Also, everyone needs finance background, and tax law. And that all enters into making a case for how important solar is and how it can be economically feasible. Different things related to buildings are important. Students should know basically how a house in a building is constructed. Environmental science is another key item. If we could stress to students the effect on the environment of turning on an electric switch, knowing that some mountaintop in the Appalachians is being removed to find the coal to generate that electricity, which is about 50% of all the electricity generated and used in the United States is used with coal, generated with coal. Project management skills, of course, in running jobs, marketing and sales skills, and a key item, which you all teach in school, is interpersonal skills. Now, there's a lot of details behind this. The next couple of charts, I won't go into any of these, but you can look at this later. Now, a little background information, which can help us just set a baseline. In Connecticut, our electric cost is between 18 and 20 cents a kilowatt hour. Most homes, medium-sized homes, would have space for maybe a 5 kilowatt system. Solar size system is limited by the utilities to 12 months of your electric usage. So you don't want to put up a system that's so big that you're going to spill too much electricity back into the grid because they won't pay you much for it. But as long as it's as much as you use the last 12 months, you'll get full state rebates and full credit for anything that you send to them. You get it back free. Just as an example, in the first year, an 8 kilowatt system would save you around 9,000 kilowatt hours, 9 megawatts, and would save about $1,700. Or, and I leave this blank for now, or if you want to use it instead to power your electric car, you'll see a slide at the end of this telling you how much money you save. And it's tremendous. Oh, there it is. I forgot I put it right here. $6,300 a year is what you would save if you had an 8 kilowatt system and you're running a couple cars, about 50 or so, 25,000 miles a year. But we'll get into that later. What I wanted to do today was just answer 7 questions that we get asked a lot, and just go through them briefly. The first one is, what are the components of a PV system? So let's start there. It's basically a simple system. It's just that the sun hitting your solar panels on your roof or out in your yard, ground mount, is all DC electricity, so it has to go through an inverter, which is shown in this slide. And then after going through the inverter and getting converted to AC electricity, it can go into your home if you're using the full amount, or if you're not using all the electricity. Some of it, being grid tied, would go through your meter backwards into the grid, and you would get credit for that, full dollar for dollar credit. Here's an example of it doesn't have to be on the side of a house. A lot of these are in people's basements, but here's an example of a system installed on the side of one of the houses we did. This is the inverter here. This is a DC disconnect down here, and then in this case we had two different groups coming in, and so we had a sub panel here. But this is the production meter. So we always put in an extra meter that is just on the solar system that tells you exactly how much you're producing. Then it goes into AC disconnect, which is required by law. In most cases, that has to be outside. So if someone comes to your house to fix a power line or something, they want to make sure that the solar isn't generating any electricity that could backfeed up to the lines and kill some linemen. So this is an AC disconnect for your system. Then, of course, it goes, and in this case, into the basement is the service panel, where it goes in and feeds the service panel. And coming from the grid, it goes through your regular meter and into the service panel into the basement here in this case. This is just another a listing of what we just spoke of. There's modules on the roof, various types, inverters. Now, inverters now, Enphase is one of the main leading companies selling those, and they have string inverters. And we'll get into the two types of inverters in a bit. Just to briefly mention, the microinverters change the electricity, the DC, coming off the panel. Right underneath the panel, you mount these little inverters, and they're per panel or per two panels, and they immediately convert it to AC. And that way, if one panel is shaded, the have panels that are all serially connected. And shadow on one panel would stop the production of all the panels in that string. Now, you can see here that there's some other components, rails that we usually put up, and then, of course, other components that are electrically oriented. A couple different versions of solar panels, both of them, but one of them is black. One of them is actually the one on the left, I believe, is polycrystalline. There's not much difference in production, although the monocrystalline is claimed to be a little more reliable. Lots more information exists on their reliability. The next chart shows just briefly what happens. It's powerful. When you put it on semiconductors, it excites the material, and the electrons get excited enough to want to go someplace, especially towards the positive P layer. So if you put wires along the top of that substrate, then they'll flow through even a light bulb, say, and give actually do some work and come back and to the other side. And this is all generated by the sunshine, which is, at this point anyway, free. Here's an example of a grid-tied system with battery backup. This one, you can see the inverters, charge controller, feeding the main panel for the home. It also, if there's extra electricity, will charge the batteries at night. The batteries, this is all dead at night, and so the batteries then would come through the controller and feed the house. If the grid is down, then that's the whole story. If the grid is up, if there's more being used than this system can supply, then the grid will supply it. So that's basically how it works. This is just some examples of some of the, here's one we did in, this was Saddlebrook, no, this was Wallington, and probably speed up here. Is solar useful in Connecticut? Do we really have enough sunshine? This is a question that comes a lot to us. So let me just take you through this real quickly. If the cost of electricity in Connecticut, like I mentioned, was about 18 to 20 cents. Here's an actual off the website of the U.S. Energy Information Administration, and so to verify that number, this is what it was. 7.4 cents per kilowatt hour, this was in 2010. So that estimate is close. Here's a map that he knows has lots of sunshine. So I'm comparing it to Reno, Nevada, and the next slide shows what we use is a PV Watts, which is a U.S. Energy website that is the only program that's really sanctioned by all the states. And so we use this to estimate the production depending on the system that we put up. And here, just for an example, we'll use almost the smallest system in the world, 1 kilowatt system. And so with a 1 kilowatt system, down here at the bottom, it tells you what is produced for a whole year. So 1 kilowatt system would give you 1,500 kilowatts in power, kilowatt hours, I'm sorry, in power, a reduction in power. But that's not the whole story. So if we go to the next slide, you can see. So let's go up here and summarize this. So in Nevada, even though they have a lot of sun, they have cheap electricity. Hartford has not as much sun, 25% less, but much better electric cost, if you want to look at it that way. we hate this number, but it's much higher. Therefore, when you want to put up solar, the last bullet here tells the story. We actually save 32% more by putting up solar across. That's a question that's asked a lot. What is net metering? I think I already covered this pretty much. You sell power, figure out the accounting once a year. And the reason for that is you're going to be producing most of your electricity in the year during the summer months. Maybe only 1/3 you produce in January that you produced in July. So because of that, it wouldn't be fair to settle up every month. They settle up once a year.
Is that in Connecticut?
Yeah. And here's just another one that says, okay, summer's high, winter's low, you get an average, and that's what you should get for a full year with the solar system. And this is, of course, another main question everybody asks. What makes a good location? Not completely south, that's not necessary. It can be off, as we'll see. Rule of thumb is the same as your latitude. Ours is 42. We found that 35 is actually better, but anything less than that, you start losing power. Roof should be in good condition. We don't like to put solar on a roof that's more than 10 years old, but it's really the homeowner's risk. They may eventually have to have them taken off for a day and then re-roofed and put back on. Minimum shading, of course, and a good size roof with not too many vent pipes or air conditioning units sitting on top of like commercial buildings. Now the sun's path is an important item to study. It varies tremendously from about 70 degrees to in midday in the summer down to 20 degrees in the winter. And so if you have trees or you have buildings next to you or some other structure that keeps you from getting sun, then you have to look at the wintertime if you want to get any solar at all across the bottom. So this is what you're going to see in the winter. But if you're going to get any hours of sun at all, this would be 10 a.m. to 2 p.m. you need to have something fairly clear, from 20 degrees up. In the summer, of course, you could start getting good sun at 7 a.m. sometimes on your roof, and then until 5 at night. This is an example of shade analysis, and all you who are teachers, I know this cold. That if you want to go, make sure they don't have anything that's sticking up higher than 20 feet above that. And of course, that's just the tangent of 20 degrees, which you all know is 0.36. And so you can use just a rule of thumb of a third. So if you walk out 100 feet and you don't want anything that's above your roof that's more than 33 or 35 feet tall. So that's kind of a rule of thumb that we use. Here's an example of some roofs that are okay. They're not all south, but they have some space and they're fairly clear. As I mentioned, ideal is 180 degrees south for an azimuth. Use north. So if your roof is facing 180 south, it's an azimuth of 180. The pitch is around 40 and no shading. And here's some details which you can look at later, but basically the impact of azimuth, which says that you could be at 120 instead of 180 and still be down value over the year. So you can be tilted, flat if you can help. If you have a roof that's 30 degrees, that's good. If you have one that's flat, you're going to be losing 84 on your panel. So for a commercial building, we usually set them at least 10 degrees so that we have some reasonable sunshine, and we only lose 10 degrees. What are we losing here? This is 40. So we're only losing maybe 8% of the sun's value. Shading is key, which will maybe this panel and this one with a big shade on it, maybe those are knocked out, but the rest of it is still good if you use microinverters. This is the instrument that's used spots to make sure we know what's the question. It's not whether we have enough sun, it's whether we have few enough trees around our houses in the south of our house. Shading can be eliminated on some panels by bypass diodes. I don't want to get into too much of this. Here's a typical layout we did on a house. This tree, though, we found out was a little bit too shaded here, so we actually ended up moving a vent here and to the other side, and we put 3 more panels here, took them out of this area, and actually used microinverters on this side of the roof, string inverters on this side. So you can make them work by doing some engineering. Number 5, how much does it cost? What are the incentives? So just to take a quick look, however, there's a 30% tax incentive. So you can take 30% right off your income tax of the cost of the whole system. State rebates in Connecticut are $1.75 a watt. If you're a commercial, instead of that, there's up to 35 cents a kilowatt hour starting next year for what they're calling ZREX. But this is commercial only. Accelerated depreciation tax deduction, of course, that's commercial only. We've had 80% electric inflation since 2001. So you're saving that if it goes up at a similar rate. Increased building value. In California, realtors have done many studies, and they almost all come out exactly 20 times the yearly savings. So if you're saving $1,000 on your house, on your electricity a year, that's $20,000 extra that you can sell your house for. So that's another thought when you're trying to look at the finances. No increase in property tax in our state, and financing is going to be available. Here's a more detailed example of a home with a 4 kilowatt system on it. As I mentioned, you get a state rebate. and it's really based on what they call PTC, which is practical test condition instead of standard test condition. So it's only about $1.50 a watt, but nonetheless, that brings a typical system down to 16,000, and then the federal tax that you save brings it down to 11, and of course your estimated home increase is 16,000. Your first year savings would be about 800. Your 15-year savings is 16,000. Your return, well, this is your after tax, would be a plus. Cash flow after taxes is 5,500 in 15 years. Simple payback is 11 years, which is still long. Now, we've pressed the Clean Energy Fund people to tell us announced. So this will be higher next year. So it might be that we can get this simple payback down under maybe 8 or 9 years, which would be great. This is kind of just the same thing, but a graphical image. And some people, of course, we all are interested in how much we're improving the environment by putting solar, so those numbers are down below here. Now, if you're just 30 cents, not 35 cents, we don't know what they're going to come out at exactly, but if they come out reasonably high, year payback for commercial. And that's a similar chart as we saw for the residential. Now, I mean, 5% inflation, we're already there. Grid parity occurs when the cost of the electricity over its lifetime is equal to the cost of the grid electricity. So over the lifetime, if you spend $50,000 on a 10K and you have no rebates, no federal help, and it inflates at 5%, you're still good to go with the grid. So your grid parity, if inflation, Academy of Sciences, and they claim that due to health and environmental costs, that the actual cost of generating coal electricity is 17.8 cents more than what's charged to the homeowners. So if you look at that, we're way past grid parity already. So just a thought for people. Now, each of the last, or one of the last questions here: can PV solar really replace gasoline? Well, we did a study here, and it comes out that he only needs then like a 2K system to actually power that car. Now, most of us, we might drive it twice that much, 25,000 a year, so we'd need a 4K. But let's assume we're the average driver. 8 panels on the roof at a cost of $7,500, and well, it's $13,000 minus the incentives that we've talked about previously. And this small system is compared to what you would need for an electric car, for a gas car, if you were going to drive it for 25 years, and it would cost instead $88,000, assuming the gas continues up the same as it has in the last 50 years, which is 5.7% inflation a year. And you would, so there's some really big incentives for doing electric. This is just a detail, and that comes to us many, many times. Of course, no, not if we don't have to. 5 acres of trees from a CO2 absorption standpoint. So 1 acre of solar and 35 acres of trees is a huge differential to think about. So cutting down your 1 tree maybe that's keeping solar from going on your south side of your house might not be too bad of an item. Here's the calculations on that. I won't bore you with those. This chart is kind of where we took an inventory of the CO2 emissions for the town. And then we also found out a few things about the town. Number one, its area is 22,500 acres. Of that, we've done an amazing job of making open space, buying open space, having open space given to us. And we have 6,000 acres of open space in town. I also did a calculation on how many acres of roads we have. You know, we cut down trees to make roads for cars, for gas cars, and we've got 900,000. Oh, excuse me, 900 acres of roads in Ridgefield, and we have 125 acres of roofs. We can talk about that. We can put full solar on this without impacting anything, probably. But if we're going to have 900 acres of roads for gasoline cars, maybe it would make sense to put up 500 acres of solar somewhere, cutting down less trees than we did for the roads, and actually produce all the gasoline that anyone in Ridgefield needs. So anyway, that's just a thought. And I won't go in any farther into that. So that's basically it for today on my portion of this. I would like to just say that I hate to end a presentation and then some people are not ready to spend $12,000 or $20,000 on a solar system. But there's things that you can do right today that can help in the same direction, and that is you can buy renewable energy, renewable electricity, and you can, it won't cost very much, something you could go on the website today and do. You can also sign up for energy home audits. You can tell your friends and neighbors about the advantages of solar, and maybe even buy an electric car for the future possibility of putting up solar. Air seal your home, add insulation. And like I mentioned, you need another car anyway. You could buy an electric. Right now, the government gives us a $7,500 rebate on electric cars. Thank you very much. There's some resource references in the back of this. John?
Thank you very much. That was really fascinating and thought-provoking, and gives, I think, everyone a lot to kind of work with in terms of concrete ways to move ahead and make change. So now we're going to turn it over to John Papa.
Just swap.
Pull up the presentation here.
That in slideshow. Well, thank you very much, Jen, for having me. Dwayne, we both live in town, and whenever I hear you speak, I always learn something, and that was really, really great, great information. So I wanted to just kind of preface this as kind of my learning experience as I've gotten involved in becoming more aware and considering the options that are out there in the world, and hopefully people that will be viewing this maybe are thinking about it, and hopefully this is a good real-world example for them. And then from a teaching perspective, the fact that ways to maybe address your students, or you could use examples here to cite to have them think about it. So first and foremost, I wanted to make two quick points, and I'm not sure how people think about this, but the first one is that obviously we're clean air, cool planet, and I wanted to make the comment that clean energy has been available since day one of the planet, if you really think about it. And additionally, climate change has been happening since day one of this planet as well. And I think that's really two important points for people to realize, because I'm going to talk about recognizing and considering things, and I think that's really two things to really kind of noodle your brain on, that these things have been happening since the beginning of time. And so let me just start my presentation here. So this is a picture of a laptop power cord, and I have a quick little short story, but really the point here is that when you're suddenly faced with the prospects of running out of power, you dramatically change everything that you do. So this quick little story here is that, you know, several weeks ago I went into New York City into one of my offices, and I forgot my power cord to my laptop. And obviously my whole day changed. I, you know, as most people, you know, kind of freaked out for a second because I had tons of work to do. My commute on a train into the city is more than an hour away, and I certainly knew I didn't have enough of battery power in my battery for a full day of work. And so when something like this happens, you really don't waste a moment. You lower the brightness on your screen. You put your machine to sleep if you're thinking. If you walk out of the office, if you're going to the bathroom, you put the machine to sleep. You might even write your notes and things that you're working on paper. You might go borrow somebody else's computer. You might go look for another power adapter. Hopefully it would be the right one that works with your laptop. You just basically wished you had more time. You wish you had more batteries and there was more time left. You wish you were smarter before you found out that you forgot your power cord. So there's all sorts of regrets that you have in regards to forgetting or losing access to that, and so to power. And so my next slide here is two other things that people have similar feelings about when they would or will run out of gas and water. So those are two kinds of similar anxieties of like similar to your power cord, that when your supply is limited or it's cut off, you all of a sudden go back to that whole things of dramatically changing things. And people in Europe, they have smaller cars, so they're impacted by access and limitations to fuel and energy. And of certainly water, we're not talking about water today, but again, same concept that when you are, you know, when things are limited like that, you value it a lot more. Now, here all of us in New England experienced our own sense of not having or running out with the two recent storms of Hurricane Irene and the October snowstorm. I think was Alfred, if that was the name of the storm. So I'm showing you a picture here of a office that I have in Ridgefield, and that was after the October snowstorm. And there was no power in town, but my little building had, we had the one solar panel here, as well as some other panels up on the roof that were covered by the snow. But again, that snowstorm I thought was a great example, again, back to that not having access to power for your laptop. Limited amount of gas. Actually, gas stations didn't work because there was no electricity to run the gas stations to pump the gas into the car. I find that really ironic. And the same thing with the water. There was no water for people to flush their toilets, or no power for your pumps to work in your house, let alone take a shower or cooking. Nobody had internet connections. Nobody had cell phones. Cell phones couldn't be charged. Laptops couldn't be recharged, and people were on edge. And that was after a foot of snow in an untimely time frame. So this building is a kind of a living example of that I'm using in Ridgefield, that powers, I'm using solar power to run basic operations on that, and I hope and plan to make it fully operational on solar power in the future. So it's again part of the experience. And the other kind of note here is that after this storm, the thing that I thought was really interesting was in retrospect, as you look at people with generators and those without generators. So it's kind of another haves and a have-nots of a different sort. Typically people are talking about money as haves and the have-nots and the economic differences, but you know, on a much more simpler level, just even having access to power is there. And even those that did have generators saw in a few days, because we were without power for more than a week, the limitations that they had, whether it was propane or gas, that they had to do. So there was, in a very short time frame here in New England, and again, from a teaching perspective, I think this is a great case study that it's kind of, it was a microcosm of how many people live in the world outside of, say, New England. Some people see this every day, where they do not have complete access to whether it be power, water, or fuel. And many of us don't even really consider it. So consideration is a real big word that I want to use today. And this was another example during Hurricane Irene of using clean energy. I didn't have any power at my house. My basement had a foot of water in it, and I used a solar panel and attached to a battery generator to empty more than a foot of water out of there. And if I didn't do it that way, there was going to be water for 8 days in my basement, which would obviously have created significant, damage, mold, and whatnot. So again, another example of using clean energy from a small-scale perspective to learn about how it works. And so one of the other takeaways is that from these two storms, similar again to the experience of losing your power cord or not having your power cord, of how fragile our standard of living is today, and the supposed, when you think about the supposed progress that we've made and how wonderful things are and how fragile that is. And we've had a chance to, here in New England, to see how quickly things could change and what could be a possible future, and of having shortages and limitations, and but also that we've so quickly forgotten that already, and we rationalize it and go back to our old ways. And I think that brings me to the point that I really want to make, that even though we are an advanced country, the United States and other advanced countries, we've seemingly lost this ability to really think rationally, recognize, and plan for moving forward with making other, making energy in a more seemingly smart and sustainable way. Seemingly, the only thing we really like to do in the United States and a lot of advanced countries is argue about it as to which one is right and which one is wrong. And while we're arguing about it, we've got marketing, as to what we need and consuming and wanting, and all of it really being more for the moment and with very little concern about the impacts and the costs of the future. And even just to highlight one of the slides that Dwayne was making there in regards to the costs, it's almost a no-brainer, but somehow we've figured out a way to go ahead and argue a case for why that shouldn't be done, which is really quite interesting. And to just go ahead and give you an example of how I was in New York City the other day with my laptop, and of course I went to lunch. I left my laptop on, and I didn't even think of the waste. But if I didn't have access to the power, I would have certainly turned it off, but I forgot. So just a very simple way that we're lulled into thinking about the cheap and everlasting supplies of resources that we have out there, and how we're kind of deceived into wasting them. And I don't know if all or many people have heard of the book of Who Moved My Cheese, but it's kind of really brings that back, and you could probably Google and search for Who Moved My Cheese. It's a very interesting short story, but apply it to, instead of being cheese, have it be energy, and I'm sure you'll get be entertained by that. So anyway, all of this really is kind of a current lack of what I see as recognizing and planning, and that's kind of analogous to the parent telling their child what they should do, eating good food instead of, say, some bad food. And as a child, they typically don't want to answer until and take advantage of your experience and your good intentions until afterwards when something bad happens. And then there is regret, oh, gee, I wish I did that, or I wish I did that, another way, or I planned. So kind of that whole aspect. Now, just for transparency's sake, I did actually buy another power cord for my laptop in New York City, so that I planned accordingly, so that when I did end up, I don't have to worry about remembering it. So I had a backup, and I think that's really important for people to do, is to plan accordingly. So on the parent kick, this is a slide here where I'm showing I was at a middle school last 2 years ago, and you see I've got some solar panels. I'm collecting it into this generator, so sun in a box, so to speak. And I was also here on the side, I'll have another picture in a moment, of my electric car. And I was teaching, or basically sharing my experiences, just as I am today, with a bunch of 6th graders about how you could make energy from the sun and store it and run things like iPods and iPads and lights and blow dryers, as well as charge your car and being able to make your own fuel, so to speak. And being a parent, as well as going back from looking at it from a way to do something, whether that be generating power, producing food, transporting, recycling, whatever the case might be important. And what I've been trying to do is really live being a true, live example out there. At least think about it, and I think that's really important. This electric car that I have here, and I'm going to show you the next slide, is just about at 12,000 miles. It's never left the town of Ridgefield. We're a very small town, but I've driven 12,000 miles in this car over the last few years. And I typically am out using it as an opportunity to explain in detail how an electric car works, and people know about it, and it's kind of funny. Most of the kids in town know about it, and they also know where I am, since it's the only one in there. And this slide here was at a nature center, the Woodcock Nature Center, that's in Ridgefield and Wilton, and I let them borrow it for about a month a couple summers ago. And there were several hundred children that drove in the electric car, and it went on their campus, as well as the parents got to see and hear about it. And while it's not the GM Volt or a Nissan Leaf or a Tesla, it did make the children, I think about the fact that you could actually move from one place to another and use electric power. And again, wanted the children and people to consider it. So with all that, I wanted to kind of just take a quick point about my background and how I got to thinking in this way, and doing some of these different taking on some of these different endeavors. So I've worked on Wall Street, continue to do so, heavily involved in technology for 20 years, and I think part of my experience in that with always working with the latest and the greatest and the fastest has been kept an open mind, which is important, I think, for how do you do things better. And so that's really was a great basis for me. I'm heavily involved in recycling. I was tired of going to the dump. I now only go to the dump once a year. I've obviously involved in electric cars. You see the one here, the one in the prior slide there. That's called a neighborhood electric vehicle. It's made not for long distance, but for in-town driving. And as I mentioned, we've gone 12,000 miles with that. I've worked on the Governor's Council, as was mentioned earlier, to introduce electric cars to the state of Connecticut. I've worked with in Wilton on their Go Green committee to talk about electric cars. I've worked with the Royal Bank of Scotland. I've worked in Ridgefield to help them get grants to consider the purchase of electric cars. I'm in the process of building electric cars, which I'll talk about a little bit. And I've also done work in Westport on getting charging stations and them having electric cars in their town. I'm actively involved in composting, both from a farming and, say, a horse manure perspective, as well as all the household items that we have there. And that's kind of really taking me to recognize from a farming perspective that nothing goes to waste. And I think I'll elaborate on that a little bit more, but that's really important. As Dwayne mentioned in his slides, the capturing of the sun, of my first point that, clean energy has been around since the beginning of time. I mean, the sun has been there. We could pretty much rely on that being there for I'm sure, a couple more million years. I'm involved with what I've learned kind of in social recycling, which is basically we're collecting bottles and things of that nature and having that money go back to our local food pantry, our food bank in town. So taking what would otherwise be considered garbage or just sending it off to the recycling center and actually, helping people that need help. Obviously, I'm involved in PV power, solar power. You saw some of the earlier pictures. Education. I've offered up my time and experience to some of the schools, to some nature centers, and I'd like to continue to do that. And I'm more than open to speaking and talking with people, or being at even anybody here who will be listening to this to their schools. The combination of electric vehicles and solar power. Dwayne highlighted that at the end of his presentation. Big proponent of that. We'll get into that in a moment. My shop, you saw that with the solar power. Clothing, again, huge amounts of resources are being used to make clothing. There's a massive amount of water used in making clothing, wasting of resources, which needs to be recognized. And then the whole aspect of localism, and we have a thrift store right near us. People reusing clothes that are sometimes in a town like Ridgefield or in Fairfield County, they're never even used. People buy clothes, and other people could use it as opposed to being thrown away. And so, in a summary of what I've kind of experienced is a real transition from Wall Street to Main Street, and from technology to more of the ecology that's out and that's there. And so, most really, again, recognizing when you are faced with limited supplies, or even requiring more effort. So it maybe takes more effort to go get coal. It takes more effort to go get oil. It takes more effort to get power to somewheres. All those things, when people recognize that it takes more effort and there's limitations, they change their actions. So all of these things have helped me in these experiences kind of change my actions and kind of experimenting as to what works and what's realistic. So what have I learned from all this? I've learned that clean energy has existed for a long time, since the beginning of time. Some since literally day one, like sun. Trees and plants, those are the most efficient energy power producing things on our machines, so to speak, on our planet. We should learn a lot more from them and recognize them. Horses, all animals that have been there, that are used for horsepower. It's what we call about a car, how much power it makes. Windmills, water wheels. Being at places like Sturbridge Village in New England, all the craftsmanship of how do you go ahead and make power, how do you do things. Farms, as I mentioned beforehand, a bike, clothes. Just drying your clothes. Clothes drying is one of the largest users of electricity in our Western lifestyle. Electric cars. I have a slide for you in a second. Electric cars have been around for more than 100 years, believe it or not. And solar panels. Dwayne noted that they've been around since the 70s. People were toying around with them in the 60s. So they've been around for a long, long time. And again, it goes back to recognizing and considering all these things, and as to how they could be used, again, for clean energy, and how we go about doing it. So this is my comment to a clothes dryer. I'm not using any power when I let my clothes out on a drying line. And again, clothes dryer, very easy to use, but it uses a massive amount of power to go ahead and dry clothes. And so I think all these things really kind of show, that this isn't new. Clean energy is not something new. We just have stopped recognizing it or looked looked the other way. This is an electric car. This car is from 1890. Okay, and I'm going to dive into the whole electric car a lot more. But again, it's been there. There were more than 400 electric car companies in the early 1900s. And so another example, and here's the motor. There's the motor that's here to run the electric car, and the batteries were here underneath the seat. So underneath the seat of this two-seater, you had the batteries. So again, progress, I really feel like it's insulated us from the costs, and we've kind of lost track of all that. Ask a child how a light switch works, where the fuel power comes from. They don't know. So I think that, again, this recognizing and considering that. And so, we talked about solar panels. These are none other than the illustrious Cylindra solar panels that are being used, and this is on top of a building that I have there. But again, panels have been around for 50 years, and so nothing really new from a clean energy perspective other than our recognizing it better. And so here's power. That solar power goes into a battery that I'm capturing in an inverter, and things here is that, again, back to my earlier comment, you cannot expect the world to change and to embrace clean energy if you don't have real live working examples of that. And I've been kind of on a mission here to go ahead and have smaller working examples for things that, whether you be a fifth grader, high schooler, or a college student, or a PhD, ways to absorb and kind of digest that this works. I kind of laughed when I plugged into this whole generating system, a vacuum cleaner off of solar power. So I want to go and talk a little bit more. This is a picture of a Volt that I was at a show at, and my electric car. And to kind of put things in perspective, again, of recognizing that clean energy and electric cars have been around for a long time, is that General Motors spent, billions of their own money and probably more of our taxpayer money in developing the Volt. Now, I showed you a few slides ago the electric car. So from 1890 to cars that are out on the market do today. So we got 100 years that we've been able to produce the same electric car. Obviously, the Volt has a little bit more bells and whistles, but an interesting point, I think, that should be taken. An electric car, mind you, was created to replace the horse and carriage that was very prevalent in New York City, in cities and towns. And I find that parallel really interesting, that a electric car in 1890 and in the early 1900s replaced the horse and buggy. And it replaced the horse and buggy because of a horse creating too much pollution, too much horse manure, and it was a public safety hazard to have too much horse manure on all the sides of the roads. So a horse, because it produced too much pollution, was replaced by an electric car, and then later on the electric car was kind of got beat out by the adoption of a gas-powered cars. But interestingly, that there was a replacement there. And gas cars in the early 1900s were under the same anxiety because there weren't very many gas stations in the early 1900s. And if you go back in history, you could see the AAA books that had locations of where you could fuel your car along the way, similar to what we'll talk about in a minute as far as charging your car. Electric cars in 2011, there's been there's a handful out in the marketplace, several thousand. So let's talk about kind of the current day of electric cars. It's still a car. It's always kind of a funny response that you get when people walk out of test driving an electric car, that, hey, it's just like a car. And of course it is, because it is still a car, it just has a different fuel. And I think that's really important for people to understand that. And the fact is that electric cars, as much as they've been around for 100 years, the current phase is really still an experiment. Volts, I think there's been about 6,000 volts sold in 2011. There might be about 9,000 Leafs. Tesla, which is a high performance, very high-end price car, has sold several thousand over the last few years. And really, again, being back to the experiment, they're still working on the production, mass production of these, and there'll be many more models, on the way, as well as other hybrid versions that are out there. Currently, in the near term, there's a decent premium that people have to pay for an electric car, but long term, it's certainly a big win. And again, highlighting Dwayne's slide about the the financial considerations, you certainly, if you're not just looking at it from a gas perspective, it's a long-term win, whether you're buying an electric car today or leasing it, or whether you take advantage of solar power. When you really run the numbers, and if you really look at the total cost and impact to not only the economy, whether that be personally, but also the environment, the impact, and the health issues. Mainstream, it's probably going to be another 10 years at least before it's mainstream. I'd say probably people, children today will be, that next generation of children will be the true adopters of electric cars, and that's why I'm such a advocate of going out there and showing them today about electric cars. And one of the big challenges today with electric cars is they do need a lot of power. They do need a lot of electricity. And Volts and Nissan Leafs, they have very big battery packs. They're 10 kilowatt battery packs or more. And as you saw in Dwayne's slides, that's more than a house uses in a day in many instances. And that's also the other reason why making your own power, discuss that in a moment, for your electric car is a very exciting opportunity. It's all about the battery. That's still the big challenge. That's really where the science and the advancements needs to take place. We already know how to make the car and have the wheels roll and have a motor go and have all the gadgetry and the readouts, but it's really the battery and how efficient and how effective and how lightweight you can make that. A battery makes up a very large amount of the cost of an electric car. It makes up a very large amount of weight for the car. So the battery is really the challenge that takes that needs to have much of the advancements. There's charging anxiety out there today. Again, as I just mentioned, when gas cars came out, there was an anxiety of what happens if I run out of fuel. It's the same thing today, and that's where there's the whole aspect of charging stations that many companies are working very hard on and getting out into the marketplace so that people have a comfort level with charging their cars. I think the charging anxiety is somewhat overblown. I believe that the fact is you could plug a car into the millions and millions of power outlets that are there and charge them, but there's a lot of discussion and dialogue on having more charging stations out in the marketplace. Lastly, is that there are other clean transportation options out there, such as hydrogen. That is another form of producing electricity that's in a car, and public transportation, trains, buses, and things of that nature, especially in cities like New York, where a lot of the buses are hybrid and electric. So I'm sure people have other questions in regards to electric cars, but these are the main comments of how the current day that we're faced with. I wanted to show you a couple pictures. This is a smart car in my working with a lot of the electric cars. We had this in Ridgefield, and it made this makes the perfect point of zero emissions. So we were driving a car inside a food store, and again, the size of it is much smaller than a lot of cars that are out there, but really just the fact of proving the point that it's zero emissions, and you don't need cars the size that they are today. This is a picture of, again, my electric car and some solar panel work that I had, and the whole aspect of charging your electric cars with solar panel, and the prospects of that, I think, are really powerful, and something that will be happening. We'll see a lot more developments on that. So before I go to that slide, I wanted to go back a little bit with my own electric car experience. So I bought mine in 2006. It's a neighborhood electric vehicle. The reason why I bought my electric car was that Hurricane Katrina had just happened. Gas prices were starting to skyrocket. I have 4 children. We were driving around town, never left town, and would go 150 to 200 miles. And I always said to myself, gee, there's got to be a better way. And I came across this car that was really the only electric car that one could really truly purchase at the time in 2006. So again, kind of experimenting with what was out there. I purchased it. It's not very expensive. It's about $8,000 for a 2-seater, and I really wanted to see how it worked. I did not buy the car to just save on gas money. I bought it to see, to kind of, again, to experiment and to see, not just about the gas savings, but really the bigger costs that are involved with that. And again, the whole point of being out there and exploring and teaching and showing people that it can be done. It's not a full-fledged, highway-ready car, but it was what was available. It's simple. People are shocked by the simplicity of it. It's certainly for in-town commutes, as maybe some of you have read, most people's travels during a day in a car are probably 20 miles or less. This car gets 25 miles to a charge, and it doesn't need a heavy, charging system. I could plug it in just like I was plugging in a toaster or a refrigerator. So again, it made people think, it made people consider. I got to see all the other different electric cars. Again, I mentioned I was working on this governor's council that was formed in Connecticut a couple of years ago by Obama's statement and desire to see, 1 million electric cars on the road by 2015. And so that's how I really got involved in this. And I also, in concert with seeing all the solar power, really got involved in thinking about how do I make my own power for this? How do I not have to pay the utility company for my fuel? And again, there's a real compelling argument to being able to make your own power for an electric car. And it's certainly also pretty disruptive to the existing state of how we have things, but that's what I think would be a wonderful progress. This is also the car that I had at the Nature Center that I showed you beforehand, and another project that we're hopefully endeavoring with the Nature Center is, while one of the biggest takeaways that I learned about electric cars is they are not that complex. There's an electric motor. There is the controlling, dashboard that how much power you have and things of that nature and what you need, the controller, so to speak, and then there's a battery to it. And so one of the things that I really believe is another compelling thing that I'm working on is to actually not buy a whole new car, but to actually convert cars from gas to electric. And it might seem a little bit out there, but if you really think about it, even the greenest, most new, car, whether it be a Volt or a Prius, uses a massive amount of resources to produce that car. Most cars in today's day and age, the only thing that breaks on it is this big beast here, this internal combustion engine. And the thought really would be, especially from a science and a teaching perspective, would be is to have kids, have children, people learn how this works. And while it is a wonderful piece of machinery, there's other options, and to consider the ability to have a simple electric car. So we are working on changing this Z28 Camaro from a internal combustion gas-powered car into an electric car. And I also think that from a science perspective, having classes learn how a gas-powered engine works versus a electric car works, when they see that, they would, I think, consider things differently. And again, generations that are in grade school, middle school, high school, and college will be your electric car buyers, and that's how you will get to a cleaner transportation and a higher adoption rate of electric cars going forward in the future by people just understanding the dynamics of that. So I think that you see all the items that I mentioned before this basically make the usage of an electric car, when you recognize all the resources and things that you're using throughout the day. An electric car is certainly a heavy resource intensive. You could go ahead and see how it makes sense to wanting to use an electric car. So with that, kind of in closing, I think the real challenge out there to both students, people, schools, teachers, is kind of a quote that my mother, who is a second grade teacher, kind of shared with me a while back that I got a kick out of, is when all men think alike, no one thinks very much. And I think this is a pretty good summary of how a lot of the world is today, where we're kind of on autopilot with all the different things that we do. And hopefully, with seeing some of the things that I've done here and are experimenting with, and hopefully as teachers that you could go ahead and challenge your students with, that we can go ahead and have people think a little bit outside of the box, or at least consider other intelligent, smart, and sustainable ways to, whether it be transport yourself or to generate energy or to reduce our energy usage. A statement here that I see that really is the U.S. as kind of a third world energy company, a country on two different levels. Mentally, as I've discussed all throughout my presentation, we don't really think about that, and we haven't really planned very well about that. And certainly the way we move our energy and transport it around our United States needs a very large upgrade in consideration. And even from the perspective that a lot of power, as Dwayne detailed in his thing, you're producing that power on your own location. The fact that you're going to transport it from the roof or from some post to your house is obviously much shorter than the massive amount of lines that we have going throughout our country. I think that people need to think a little bit more away from a return on investment mentality to a reduction of cost focus. So as you're reducing your costs on whether it be your house or your transportation, that will certainly become a very powerful focus to think about how you're reducing your costs, because there's certainly a lot less money in the world today that people are going to want to be investing. So the better way to, instead of trying to make more money, would be is to reduce the costs and the spends that you have to do. The whole point of hopefully the ability to show people and to let people think about being energy independent at a personal level. I know the country talks a lot about, and a lot of people talk about, being energy independent as a nation. That's certainly something to work for, but at the same time recognizing that you could be energy independent yourself, I think is something for people to consider. Again, summarizing, younger generation recognizing, understanding, and exploring options for more intelligent ways, whether that be for clean energy, for your transportation, is important. And a point I made to a lot of during a lot of the presentations, especially to younger audiences, is that in the 1980s, especially in the early 80s, there were no cell phones, there were really no personal computers, there was no internet, there was nothing. And today, all those things are here and seemingly foundational pieces of how people operate in the world. all those things were very resource intensive. Think about all the natural resources that go into making PCs, cell phones, and the internet, and it's very expensive. I think in the 2010s and beyond, we're going to have resource constraints, and it's going to be even more expensive. So the ability to think about the reusage and having low impacts are really important. And to think that if cell phones and PCs and the internet didn't exist 30, 40 years ago, what wonderful things can we do and produce and develop and invent over the next 30 years to again have less of an impact on our environment and our economy, and to be able to go ahead and do that in a more intelligent way is what we need to challenge our younger generations with. So I think that's the end of my slides and my time, and thank you very much.
Well, John, thank you. You've likewise given everyone a ton to think about and a lot of material to work with. We did want to save a little bit of time for Q&A, and we do have a little bit of time left, so we're going to try to sneak in as many questions as we can in the next 5 or 10 minutes. And I wanted to start off with this one. John, you referred several times to kind of energy independence, and mentioned some of the extreme weather events over the last 6 months in Connecticut, and how having distributed energy might be a benefit or a way to avoid that being stuck in that way. But Dwayne, in your presentation about solar, a lot of what you were talking about involved net metering connecting to the grid. And so a couple of questions about that. If you have solar panels on your building or your home and the grid goes down, is it true that you're going to lose access to that power, even if it's being distributed right there on site? And if so, is there a way around that? What should people expect? And if they don't want that to happen, is there any way they can avoid that?
Yes, it is true that if you're grid tied and you don't have any batteries installed, then unfortunately you're going to lose all your power. And there's a good reason for that, and that's just the safety of the linemen. They've required all inverters to automatically shut off if the grid power goes down, so that there's no danger there. Obviously, as that one slide that I had the picture where you do have batteries, if you're willing to spend a little more money and install batteries, then you will have power when the grid goes down, because there's a bypass that allows the solar to continue, and you can charge your batteries and also run your house off your batteries. Recently, we've thought of another way, and that is if you have a hybrid car or an electric car, instead of buying batteries, you could use that as your battery bank in snowstorm times or when the grid is down by connecting that to an inverter and then to your house grid. That has to be done safely, of course, but that's obviously another battery bank that's wandering around the streets.
Hey Jen, I can just add, I think too, a point to this is that during some of those storms, that when I was showing you those pictures of those solar panels for the sump pump and at the office, and we also had that at our house, that was all mobile. That fit in the back of my Jeep, and I think the point was that was really a great learning example for a lot of people to see that, hey, there's no power, but you're able to, we charged our phones, we charged our laptops at night after we were kind of tired of looking at candles. We actually, put our a lamp with CFLs in it and LEDs. We turn that on, and it's a very small draw. So I think that was a small example of capturing power when nobody else had power, and how you're able to use that. And I think that's really an important point for people to do, just even on a small scale. Have kids learn how that works.
Yeah, it definitely made me want to go out and get a solar panel so I can have my own kind of quiet, fuel-free generator for the next generator of sorts for the next emergency. Could you talk briefly about how complicated it is to have something like that? I mean, were you able to do that because you have sort of engineering and technical background, but it's something you would need to have expertise to be able to do, or is that something that anyone could go out and get a solar panel?
I think that's a really good question. I am certainly no engineer by any stretch of the imagination, and I think that's one of the points is that, again, since solar power has been around for so long, they've done a great job refining what's there. So, I mean, there's really a solar panel that's connected to an inverter and a battery. There was that one picture. I don't know if the screen is still live here, but that's where this red and black wire basically went to the solar panel, and that's sending the power into the battery. And so some of that was off the shelf. These were things that you could buy, whether it be some of it at Home Depot, some of it through different farmers' catalogs. And Dwayne and I have actually worked together on small-scale ones where, I'm certainly not the engineer about putting all that together. So it is not massively complicated, and I think that's why it's great for the kids to learn in school. How to do that, and you could do it even on a smaller scale. It could be a smaller solar panel, and it could be a literally a car battery that you work with to just even charge your phone or an iPad or run a lamp or a laptop.
Yeah, that could be a really interesting school project. Okay, so a couple of other questions. This one is a little bit, shifting gears a little bit, but so Dwayne, towards the beginning of your presentation, you talked about how, making the solar panels also you need energy to make the solar panels and materials to make them, but that if you look at it from a life cycle perspective, that it's still, after a year and a half, you've sort of paid back that energy, so it's still a better bet over the long term. One of the things that come up sometimes in conversations are not only about the energy that it takes to create the solar panels, but the materials. So people are curious about if there are either rare or toxic materials that it takes to make either the solar panels or the batteries, and if so, the degree to which that's a problem or likely to continue to be a problem, or the degree to which research is currently going on to try to find alternatives. Could you talk a little bit, either of you really, about the kind of toxic or rare materials that are required to make either the solar panels or the batteries, and if there's anything people should know about that?
Yeah, excuse me. I think a lot of the there's two issues with the that you brought up. One is the solar panels, but I think most of that is concerning the thin film panels. The regular panels that we've been using for many years are basically just like silicon chips, and they really don't have any wild toxic materials in them. The batteries is a different question. I really don't know much about that, but maybe John can fill in.
Well, of course, a battery has all sorts of natural resources in it that are there. I mean, in a certain regard, there's kind of a, it's kind of hard to go zero as far as not having any impact. I think the real, thought about some of that is I think right now it's kind of a one-to-one. Dwayne talked about parity as far as the cost, solar versus other grid power, and I think one of the really important things to look at is we shouldn't be thinking about just replacing our current operate, current way how much power we're using. I think we waste. I think there's a percentage of like 20% of our energy that we're generating into the grid gets wasted, whether it be from transmission or whatever the case might be. And then if you think about it, my example of, I left my computer on, when I went to lunch. When I was running out of power, I certainly didn't do that. So I think that anything that's man-made is using a resource. So there's a combination, and that's why I kind of cited all those other things of really recognizing the ability to let's just not try to figure out how to make as much solar power as we make out of coal power. We should be thinking about how to, be much more efficient and effective with it, as opposed to just, making the same amount of power, whether that go for a car or for running your house or whatnot.
And to that point, I guess it sort of goes on to another question, which is about kind of the convenience factor. And I'm wondering, again, both for the tenant or homeowner or business owner relying on a solar PV system or someone using an electric car, are there kind of changes in practice that might initially be perceived as inconvenient or just sort of a habit that needs to be changed? So for example, with the electric car, people, for a while, everyone was buying SUVs because they were bigger and everyone needed more space. Are there constraints that either relying on a solar PV system or relying on an electric car present, or is that a myth? Are there things that maybe it just changes in habits?
Yeah, as far as solar is concerned, if you're connected to the grid, there's nothing that you do different in your household. So there's no habit kind of issues there. As far as the electric car goes, I'll let John answer that question mostly, but I just want to say that the only issue there would be to remember to plug it in at night and get it charged up again for the next day. So that's a small change, but there's other things if you're going to go on a long trip, and John can address that maybe.
In regards to the electric car, I was originally a little bit turned off by the Volt because it still did use gas, and I have to hand it to General Motors that I think they were 200% right with making it the way they did. Currently, there is that anxiety about running out of electric power. They've basically squashed that whole concern by the fact that it's an electric car that uses its battery power as much as it possibly can until it's emptied, and then when you run out, you get to use a little, you use gas. I think it's got a 3-gallon gas tank that basically turns a generator on to power the battery and recharge it and to run the electric motor. So it's still always running as an electric car. And I think that there's a transition time because of people's anxiety, and they don't want to be inconvenienced by having to think about that, so that now a Volt could go, I don't know, it's like 300 plus miles or close to 400 miles on electric power and in concert with gas power. So I think they've done a really smart job in helping the the population, the adoption of electric cars by giving them kind of that safety blanket to do that. And that's so that people do not have to change their habits very much at all. People that are buying a full electric car, I could certainly tell you that it is something you have to think about, but again, it's no different than in the old days when gas-powered cars came out and there weren't that many gas stations out there, or if you were having a horse and buggy, your horse would get tired or you have to feed it or whatever the case might be. So it's nothing that humanity hasn't faced before. But I will tell you that I think that from a convenience factor, if you really think about it, they call a gas station nowadays a convenience store. And I happen to think that it's inconvenient to have to drive somewheres to go get fuel to put in your car to then go back home. It's seemingly much more convenient when you get home at night and you're done with your day at work, You plug your car in just like you plug your cell phone in, and it's ready for you in the morning. That's convenient, as opposed to the inconvenience of going to a gas station. And I think, again, from a marketing perspective, we've been deceived and duped into that. I'm sure I'm going to get some good feedback on that, but that's the reality. It's not convenient.
No, I'm with you. I hate stopping for gas.
And a gas. If one other point, I mean, a gas station doesn't really make money selling gas. They make money selling you milk and potato chips and candy bars and all those other things, cigarettes that you don't need.
Maybe we'd be healthier too.
Yeah, there you go.
Okay, so last question for you guys. So for today's students, elementary, middle, high school students, college students, who are really interested in this, can you talk a little bit about what you see as the kind of big problems to be solved in the future or opportunities to contribute? What's the sort of future of the field, and what are kind of the big challenges that today's students hopefully are going to get to tackle in terms of advancing the use of solar energy or electric vehicles or other clean energy for that matter? Any great gauntlets you want to throw down for today's students, the problems that they need to go out and tackle?
Well, for a starter, they need to be serious about learning mathematics and engineering if they're interested in doing that. And there's going to be a huge need for people that can put systems together, design them, and if they're interested in research, of course, there's a huge need for improving all these products beyond just designing systems for existing places. But the other big need is in marketing and sales. This is a industry that has hardly been tapped, and people that want to go in business and sell systems, and installers, of course, if they're not interested in the other jobs, and also finance. If we had good finance, that's easy, everyone would put these up practically. So there's huge opportunity for all types of fields, including management and, like I mentioned, in marketing. John?
I think that's a great question, and I think that being from, having kind of entrepreneurial and starting businesses, I happen to believe that there's no roadblocks other than, our own and kind of the embedded industries that are there that don't want something to change. And so I think that it presents a huge opportunity, literally just scratching the surface. I mean, we talked about electric cars being around for 100 years, solar panels being around for 50. I think the ability for people to be able to, again, give it consideration, to recognize that they could produce their own power, they could go ahead and reduce their costs. I mean, those are all things that, the world certainly needs a lot more of. And, I think it does come down to, having an independence. Everybody wants financial independence. Well, there's, other independences as well, such as energy, that I think will become more and more challenging as we go forward. So I think it's a huge opportunity to kind of just, again, kind of peel back the onion and look at these things that we've just thought, gee, that's the way it works. I mean, when I was growing up, when I was in college, I didn't think about, how am I going to access the Internet? It didn't exist yet. So look how many jobs between Microsofts and the Apples and the Intels of the world and all these things that are out there. So, there's an opportunity for that to all happen all again on some real basic foundational pieces of society, and that's, power and transportation.
Sounds like the future's wide open.
Yep.
Well, listen, I want to thank you both very much for being with us today and for taking the time to share your important work with our audiences, and appreciate your presence, and look forward to talking with you both again soon.
Thanks so much for having me.
you. All right. That concludes today's program. Appreciate everyone listening. Thank you, and goodbye. Okay, I'm ending the recording now. You guys don't actually need to hang up, although we're a little bit over time, so maybe you want to hang up.